Greetings to all. In this video, let's see an example problem for convolution coding. Okay, the question is draw an 1 by 2 rate convolution encoder with constraint length 3 and decode the message bit 1001 for the generating sequence G1 equal to 111 and G2 equal to 101. Draw the encoder diagram, trellis and state diagram. Also track the output sequence using the code tree. Okay, so if you see this question, we could see the code rate is given. Okay, so code rate is 1 by 2 and the constraint length, okay, is given as 3. Then we have the message bit that is given as 1001 and the generating sequence G1 vector and G2 is given. Okay, G1 is 111 and G2 is 101. Okay, so what is asked is draw the encoder diagram, trellis diagram and state diagram. Also we are asked to track the output sequence using code tree for the message bit 1001. Okay, so if you see from the given question, code rate is given. Okay, so code rate is nothing but 1 by 2. Okay, so 1 by 2 here it denotes, okay, k by n, that is each message bit has an output bit of length 2. Okay, so code k by n, so the small k is 1 and n is 2, so a single message bit is going to have an output bit which is of length 2. Okay, so the first question is, draw the encoder diagram. So encoder diagram is nothing but consists of shift registers and also a logical circuit. So shift registers are memory states, and here this constraint length is 3. Therefore, we are going to have 3 memory states, okay, in the shift registers. So with the help of the generating sequence G1 and G2, that is going to influence the output, and so which we can define it as x1 and x2. So the constraint is, okay, so constraint is nothing but number of shifts over which a single message bit can influence the encoder output. Okay, so let's start with the encoder diagram. So as I told, encoder diagram is nothing but consists of shift registers and logical circuit. And first, okay, since the constraint length is 3, we are going to have 3 memory states, like it's defined as m, okay, m0, okay, m1, sorry, let's take as m1, m1 and m2. Okay, so every message bit, okay, every message bit comes to a state m. Okay, so when new message come, this new message gets shifted to m1, and whatever is there in m1, which is the previous message, is shifted to m2. Okay, so the shift registers stores the memory of the previous messages, the last 2 messages. Okay, so when a new message comes, it gets shifted. Okay, it gets shifted by a factor of 1. Whatever is in m will go to m1, and m1, and then the data in m1 will go to m2. Okay, so so m is a state where the input bit comes, and m1 and m2 forms the states. So this m1 and m2 is used to represent the states of the shift registers, and every new messages comes to m1. Okay, so as I told you, the encoder diagram consists of shift registers and logical circuit. So logical circuit is defined by m1 and G1 and G2 vector. So let's take G1 generates an output x1. So this G1, okay, and this is G1 has a code vector, has a vector of 111. That is, it is an XOR between m1 and m2. This is connected to all the 3 memory states, okay, m1 and m2, since a 111. So what I'll do, I'll just have an XOR operation here. So this is connected to m is connected M1 is connected and M2 is connected. Okay, I'll take this as X output X1. Okay, so we told each message bit has two output states because the code is 1 by 2, and the second G2 vector is 101. So second output X2 is only connected to M and M2. Since we have 0 here, M1 is 0, so the diagram is this is connected to only, okay, M and M2. Since we have 0 here, the M2, okay, yeah, M2 M1 is not connected, so the output X2 is nothing but M XR M2. So X1 is nothing but M XR M1 XR M2, where X2 is nothing but M XR M2. Okay, these are the basics for solution. Okay, so this is the encoder diagram. Okay, this is the encoder. This forms this X1 and X2 forms output. So for each message bit, we have one bit, one output from X1 and one output from X2. This both combined together to form two pairs to get 2 bits for each message. Okay, so then this is the encoder diagram. So before drawing the state trellis and state diagram, it's important to draw the state table. Okay, so state table is very, very important because if the state table is correct, it is be very easy to draw the cell diagram, trace diagram, a state diagram and code tree and everything. So let's start with how to draw the state diagram. So we all know that, so we have like first 2 bits combined together, to form a states like the encoder states. So let's take 0 0 as A, state A, 0 1 as state B, and 1 0 at state C, and 1 1 as state D. Okay, so this is our M2 and M1. Okay, this is our M2 and M1. Okay, 0 0 is state A, 0 1 is state B, and 1 0 is state C, and 1 1 is state D. Okay, so as I told you, it's the important thing that we are going to find first is state table. Okay, so state table consists of nothing but the present state. Let me mark it down. The present state. Okay, the message, okay, then the output, okay, output and the next state. So let me just simply draw a table and freehand table. Okay, so present state, I told you we have 4 states. Okay, we have 4 states. Okay, we have 4 states. What are the 4 states? 0 0 0 1 1 0 and 1 1. Okay, so this is M2 M1 and this message is M, and output is X1 and X2. Okay, and next state again we have M2 and M1. Okay, M2, I'll tell you what is M2, and we have M1. Okay, so we have 4 states, right? What are the 4 states? 0 0. Okay, that is state A, right? Let me draw a line here. Then 0 1 we have, which is state B. Okay, then we have 1 0, which is state C, and 1 1, which is nothing but state D. Okay, so what we should know is every state, okay, every state we have 2 possibilities. So I told you very clearly, when a new message comes here, like we have a shift, whatever in M will go to M1 and M1 will go to M2. So whenever new message comes, there is a change in state also. Okay, so whenever there's a shift, the next state is nothing but M2. Okay, whatever is in M2 will go, whatever is in M1 will go to M2. So M2 is nothing but M1. Okay, next state M2 is nothing but M1. So what is M1? M1 is nothing but M. The next state is when a new bit come, whatever is in M will go to M1. So M1 is nothing but M. Okay, so M1 is nothing but M. Okay, so 4 states. So each state there are 2 possible. We are going to just in the state table we are going to just mark out all possible combinations. Okay, so we have like 0, 1, 0, 1. State A we have 2 options. Missing bit can be 0 or 1. Again, state B we have 2 options. Missing bit can be 0 or 1. Again, the next 2 states, state C and D, it can be of 0 and 1, and state D also can be 0 and 1. Okay, so what is output state? Okay, here it's asked us, we have to mention what is output. So output is nothing but, we know very clearly in the encode diagram we have marked it. Output is nothing but x1 is equal to m xr m1 xr m2 and x2 equal to m xr m2. So this is nothing but x1 is nothing but m xr m1 xr m2 and x2 is nothing but m xr m2. Okay, so we are going to just find the output first. So let's try to find the output. Okay, let's try to find the output. So what is x1? X1 is going to be m xr m1 xr m2. So 0 xr 0 is 0, 0 xr 0 is 0. Again, x2 is nothing but 0 xr 0. So what is XOR operation basically? So XOR operation is, I think you must be very aware of it. If it's same, the output is 0, different sign is the output is 1. That is 0, 0 is 0, 1, 1 is 0, 1, 0 is 1, and 0, 1 is 1. Okay, so what is this? What is the output for this state? Okay, x1 is m xr 1 xr 0 is 1 and 1 xr 0 is 1. So x2 is m xr m2, 1 xr 0 is again 1. Okay, so what is this? m xr m1 xr m2, right? 0 xr 1 is 1, 1 xr 0 is again 1. So what is this actually? What is x2 here? 0 xr 0. Okay, 0 xr 0 is again 0. Fine. So what is the output if the input bit is 1 in state B? Okay, so it is 1 xr 1 is 1 and 1 xr 1 is 0 and 0 xr 0 is again 0. Then x2 is 1 xr 0, that is equal to 1. Okay, so here it's 0 xr 0 is 0, 0 xr 1 is 1. Okay, 0 xr 1 is, x2 is 0 xr 1 is nothing but 1. So here x2 is, for if the input bit is 1, it is 1 xr 0, that is 1 xr 0 is 1, again 1 xr 1 is 0. Okay, then we have 1 xr here x2 is 1 xr 1, which is going to be 0. Okay, the last state x1 is the input bit is 0, the input bit is 0, we have 0 xr 1 is 1 and 1 xr 1 is 0, right? Then we have 0 x2 is 0 xr 1, that is nothing but 1. Okay, so what is this thing? 1 xr 1 is 0 and 0 xr 1 is 1. Then we have 1 xr 1, for x2 it is 1 xr 1, it is 0. Okay, so what is next state? It's very easy to fill. M2 is M1 and M1 is nothing but M. So whatever is there in M1 you can write for M2. So we have M1 is these values which is nothing but 0 and M1 is nothing but M, that is 0, right? Then this M1 is nothing but 0, again M is nothing but 1. Okay, so m2 is something but m1, which is nothing but 1. Again, m1 is nothing but 0. So I'm just making it fast. It's going to be like 1 1. It's going to be like 0 0. It's going to be like 0 1 0 1. It's going to be like 1 0 1 0, and it's going to be like 1 1. So what are these states? 0 0 means it is state A. This state 0 1 is state 0 1 is state B, and 1 0 is state C, and 1 1 is state D. Again 0 0 is state A. This is 0 1 is state B, 1 0 is state C, and 1 1 is state D. So what we observe, the state table is very very important. Okay, the state table is very very important. So what do you observe here? So what we observe here is, if the current state is A, okay, and if the message bit is 0, the output is 0 0, and next state is also A. Okay, if the present state is A and the input bit is 1, then the output is 1 1, and next state is B. Let's come to states here. If the current state is C, okay, if the present state is C, and if the input bit is 0, the output bit is 1 1, and next state is A. And if the current state is C, the input bit is 1, and the output is 0 0, and the next state is B. Okay, so similarly, this is how we should try to represent the state diagram, state table. Okay, A, B, C. What is the current state? What if the input, whenever you have a new input 0 or 1, what will be the output, and what is the next state? This is what we should know. So this state table is going to help us a lot in helping us to draw the Trellis diagram, state diagram, and also the code tree. Okay, so let's with the help of the state table, let us continue with the Trellis diagram first. Okay, Trellis diagram. Okay, so let's begin with Trellis diagram. Okay, so in Trellis diagram, we are going to say, what are the two states we have? Let's see this this table. I told you this table is going to be very important thing. So we are going to have the present state and also the next state, right? Present state and also the next state. This table is going to help us a lot. Okay, so here let me say, we have two states, present state and next state. So this present state, next state. Okay, so what are the four states we have? A, B, C, and D. Right? Even the output state, the next state is also, it's going to be among the four. It is A, B, C, and D. Okay, these are the four states. Okay, so we are going to draw this. So one thing you should remember: the input, if the input bit is 1, it is represented by 1. Okay, 1 is represented by solid line. Sorry, dotted line. Okay, dotted line, and 0 is represented by a solid line. Okay, 1 is represented by a dotted line, 0 is represented by a solid line. Okay, so from the table, please tell me, if the current state is A, if the message bit is 0 and the next state is also A. I told you 0 means it is dotted line, right? So if the current state is, let me mark here 4 points. Okay, let me mark as points. It will be easy to mark it down. So if the current state is A, the input bit is 0, the next state is also A. Okay, fine. So this we're going to put an arrow mark, and what is going to be the output for this? 0 0. We're going to see the output here. Output is nothing but 0 0. Okay, nothing but 0 0. So what happens if the current state is A? Okay, if the current state is A and the input bit is 1, the output is 1 1, and next state is B. Okay, input bit is 1. 1 means we need to draw a dotted line. So next state is B and output is 1 1. So current state is A. Okay, current state is A. Okay, input bit is 1, next state is B, output is 1 1. So B is here. I'm just going to, output is going to be 1 1. Clear? Okay, now let's see the table. So let's go to the next state. Okay, so from this table we understand we have finished for state A. We go to state B. Okay, so if the current state is B and the input bit is 0, it goes to C. If the current state is B and the input bit is 1, it goes to state D. Okay, and the output is going to be 1 0 and 0 1. Okay, so next is going to be from the B, it's going, if it's 0 it's going to C, and if it's 1 it's going to D. So 0 means, I told you, it is an solid line, and 1 is going to be an dotted line. So you need to mark the output. So output is for state B, the output is nothing but 1 0 and 0 1. Okay, so let me keep it aside. 1 0 0 1. Okay, let's go to state C, third state. From the table, the current state is C and the input is 0, it's go to state A, and if the current state is C, input is 1, it goes to state B. So C, from state C, if it's 0 is going to state A, and for 1 is going to state B. The output is going to be 1 1 and 0 0. So it is going to state A, then it's go, if it's 1 it's going to state B. Okay, if from the current state is C, if it's 0, the output is 1 1, and if it is the input from the state C, if it is 1, the output is going to be 0 0. Similarly, we need to draw for D also. So from the table we see that if it's 0, from state D, if it's 0, it's go to C, and if it is 1, it's go to state D. The output here is going to be 0 1 and 1 0. So you can see it in the table itself, just show to you. So for D, it is, if its input bit is 0, it's go to state C, and 1 it's going to state D, and output is 0 1 and 1 0. It is 0 1 and 1 0. So this is your trellis diagram. Okay, this is your trellis diagram. Next, we are going to see the state diagram. Okay, now we will see the state diagram. So what are the 4 states we have? Like, we have like 4 states, right? Like state A, state B, state C, and state D. Okay, we have 4 states, right? This is state A, this is state B, I'll take this as state C, and this is state D. Okay, same concept here. For 0 we represent a solid line. Okay, a solid line. For 0 it's a solid line, and for 1 it's going to be a dotted line. Okay, we are going to use the same table, or we can just use the same table to draw the trellis diagram, or else we can also use we can draw it from the trellis diagram also. So let's see from here. that if current state is A and if the input is 0, the next state is A and output is 0 0. Okay, so let's draw it. So if the current state is A, okay, the next state is also A. Okay, the output is going to be 0 0. Okay, let's take it from the Trellis diagram. So if the current state is A, if the input bit is 1, the next state is B and the output is 1 1. Okay, 1 1. So how will we draw it? The current state is A, the input bit is 1, the next state is state B, and the output is 1 1. Okay, so if the current state is B, input is 0, it is C, and 1 it is D. So from B it's go to C, the input bit is 0 and 1 is go to D, output is 1 0 and 0 1. Okay, so from B if it is 1, it's go to C. Okay, the output is going to be 1 0. Okay, so the input is going to be 1, it's going to D. Okay, so 1 means it's going to be an dotted line. Okay, so here the output is going to be 0 1. This comes from the straight table. Okay, we are finished. So let's compare for D, C and D. So C goes to AB. If input bit is 0, it's going to A, 1 is going to B, and D goes to CD for 0 and 1. So correspondingly, let's also mark the output also. Okay, let me complete this. So from C, okay, if the input bit is 0, it's go to state A. Okay, from 0 it's go to A. So okay, it's go to A. And what's the output? Output is going to be 1 1. Okay, output is going to be 1 1. So if the input bit is 1, it's going to state B. 1 means dotted line. Okay, so it's going to be arrow mark should go this way, and the value is output is 0 C. Okay, similarly from D, okay, if the input bit is 0, it's go to C. Let's go to C, and the output is going to be 0 1, and the input is going to be 1. D is going to remain, next state is also D, and the output is going to be 1 0. So hope you understand how to draw the state diagram also. Test 4 state. Please understand 1 represents a dotted line, 0 represents a solid line. So we have 4 states. So this arrow mark conveys, like, from the current present state A, the next state is B, and the output is going to be 1 1. From the current state is A, the next state is also A, and the output is going to be 0 0. So this solid line represents the input bit 0. This dotted line represents to be 1. So let me just give one more brief one more thing. The input bit is B. If the current state is B, input bit is 1. That is solid dotted line. Our next state is going to be D, and the output is going to be 0 1. Okay, this you can draw from either Trellis diagram or from the state diagram. Okay, the last one is code tree. Okay, let's start code tree. Okay, so code tree is, again, for everything the fundamental is the state table. Either you can use a state table, or you can use the subsequent what you have seen, diagrams you have seen. after state table. You have seen Trellis diagram, or you can use a state diagram to draw the code tree also. Okay, so for code tree, let's take the first state is state A. We'll start with state A. Okay, the first state is state A, and code tree. Okay, so imagine like it has two branch. Okay, the upper branch and lower branch. Okay, so whenever the input bit is currently, take the state A, whenever the input bit is 0, it always take the upper branch, and whenever the input bit is 1, it actually takes the lower branch. Okay, so if the input bit is 0, it takes the upper branch, 1 it takes the lower branch. So from the table you know very well, if the current state is A, okay, if the current state is A, if the input bit is 0, the next state is also A, and if it is 1, the next state is the next state is B. Okay, so if the input, I told, if it is 1, see, if it's 0 it takes the upper branch, 1 it takes the lower branch. If it is 0, okay, the next state is also A, and if it is 1, the next state is B. Right, next state is B. And what is the output here? Output here, it is 0 0, here it is 1 1. Right, 0 0 and 1 1. So again the same thing. So now it's the current state is A. It, from this you have to again start again. Okay, from here it goes to state B, it goes to state A again. Okay, from A, the input bit is 0, it goes to state A. If it is 1, it goes to state B, and output is 1 1 and 0 0. Okay, let's come here. Now the current state is B, the input bit is 0, it goes to state C, right, C, and if it is from the current state B, the input bit is 1, it goes to state D. Okay, the output here is 1 0, and here it is 0 1. From where did I get this? It's nothing but from the state table, right? You can see it, you can see here, you can see here, it's from B it goes to C D, and output is 1 0 and 0 1. Okay, what about the third state? So the third state is from C it goes to AB, and D is go to CD. Okay, we're going to continue in that way. So we're going to continue 1 or 2 more steps. Okay, that's it. So from C, okay, if the input bit is 0, okay, it goes to A again, and 1 it goes to B. Right, so what is the output from C? If it's go to A, the output is 1 1, and if it's go to B, the output is 0 0. So from D it's go to C D. Okay, if it is 0 it goes to C, and if it is 1 it goes to D. Okay, similarly you can continue this. Let's continue for one more step. Let me stop here. So we have a question. Okay, we see the question. What is asked in the question is, you see the last question, also track the output sequence using the code tree for the message bit. Okay, the message bit given is 1001. Okay, track the output 100. So we need to track the output for the message sequence 100 using code tree. Okay, this is 1001. So from here, okay, from here let me use this pen. Okay, where is 1? Okay, from CD, where is 1? 1 means it should come down, right? 0 means, I told you, 0 means up and 1 means downward. So 1, from 1 it goes to 0, right? 1 0, it has come to 0, then again it is 0. right? 1 0 0, then it is 1. We have stopped here. So let me just proceed for one more step. Okay, so we have only finished for 3 steps. We have like this is 1 0 0, again it should go to 1. So let me only for this I'll take one more step. So this, if it is A, it's go to, so we have 1 1. Okay, so A, it's go to A and it's go to B, right? And the output is going to be 1 1 and 0 0, if I'm not wrong. Okay, so this is 1 0 0, again it is 1. So 1 should go down. Just track the output here. Okay, what we're going to do is we're just going to track the output. Okay, so that is okay. So first is 1 0 0. So for 1 1, okay, the output, okay, let's take it x. The output is, the first one is 1, right? What is the output here? 1 1. Then 0. For 0, what is the output here? 1 0. Then we have again 0. 0 means it is 1 1. Then it is 1. 1 means also output here 1 1. So this is the output. So question is track the output for the sequence 1 0 0 1. The output is 1 1 1 0 1 1 and 1 1. So this is the answer. So this is one of the very basic and important topic in convolution reports. Hope that I have covered all the basics. If you have any doubt, you can ask me. Okay. So let me just give a small glance. Okay. So what we have done is given the following. So given the code rate, constraint length, generated sequence G1 and G2, and message bit 1001, we are asked to find the encoder diagram, Trellis diagram, state diagram, and also track the output. Okay, using code rate. Okay, so it's from the constraint is given as 3, and the code rate is 1 by 2. That is 1 bit is going to have 2 bit output. Okay, so since the constraint length is 3, okay, we have 3 memory in the shift register, okay, M1 and M2. Whatever the input bit, okay, this is your input bit, comes to the M, and whenever a new bit comes, the bits get shifted. Whatever is M will go to M1 and M1 will go to M2. You know, the state changes. So M1 and M2 will form the states, and it's nothing but the previous message inputs. And whenever new input comes, the state changes. Okay, so the output also changes. Output is, each bit is going to have 2 output bits. It is x1, one from x1 and one from x2. Okay, so from this we do the state table. Okay, state table is very important, and this is just an assumption. Please, you can make this assumption fixed so that you know the table remains the same. So like you can draw the state table. Okay, what is the present state? What is the next state? What is the message? If the message bit is 0 1, what is going to be the output, and what is going to be the next state? Because every time a new message comes, the state changes. So whenever a new message comes to the present state, what is the value in the output and what is the next state? We are going to find for all the we are going to find for all the different combinations of the message bits, and then we can draw the Trellis diagram. Trellis diagram is nothing but what's the present state, next state, and we have forced it's ABCD. 1 represents the dotted line, 0 represents solid line. Like on the table you can draw it. Okay, so then we can draw the state tree, right? State diagram, like 1 ABCD. Again, 1 represents the dotted line, 0 represents solid line. So this is a state diagram. Then followed by we have the last one, what we saw, the code tree, right? Code tree I have explained you. So whenever let's start from the first state A, and the upward branch, the upward direction is for input bit 0, and downward direction is for input bit 1, and so from current state A, input bit is 1 equals to B. Again from B, what is the condition if it's for 0 and 1, and there is C and D. From C again, what's the condition for 0 and 1. So once you mark this tree, okay, you can just track the output for the input sequence, like 1 0 0 1. Why it is down? Since it's 1, whenever I told you very clearly, whenever the input bit is 1, no, it should move in the downward direction, and if it's 0, it's moving upward direction. So this is the output. Okay, so thank you for watching patiently.